Hi everybody. Just thought I'd give you a brief overview of how to do some basic viewing of HTML in Swing. This is important because it enables us to access the so-called presentation layer in our networks so that we can take HTML data out of the substrate and show it to the user. And what you're going to learn in this section is how to build an HTML viewer. You're going to learn about multi-purpose internet mail encapsulation data types, which is important because it helps us to determine the data type that's being supplied. And we're going to learn how to synthesize HTML, and we'll learn how to generate some HTML forms in programmatic fashion using Java. So when we look to see where we are in the network layers in terms of the big OSI model, physical layer might be synchronous optical networks, or SONET, that's bits. You could have a data link layer such as PPP or asynchronous transaction mode transmissions. PPP is point-to-point protocol. Then comes the routing role, which is in the network layer for internet protocol, for example. There's the transmission control protocol, or TCP, which typically is called TCP/IP in the transport layer. There's a session layer where logins are done. It creates connections. There's a presentation layer, and that's where you'll see your HTML. And so when we think about the application layer, that's kind of where we're at now. We're going to take the process data, the HTML data, and we're going to present it to the user in an application that we write ourselves. So we'd like to be able to interpret the HTML, maybe do some screen scraping or data mining, but more importantly we want to be able to show this to the user. And so then the first question is, well, how do I know what kind of data I'm dealing with? And the answer here is, well, we use the stream sniffer. And the stream sniffer grabs onto the first few bytes of a stream, and we can push those bytes back into the stream, but by sniffing at the bytes, and it's probably the first 6 or so bytes, we'll be able to get the magic number that's used to determine what type of data we're dealing with. And browsers need this because they can't rely upon suffixes in file systems. So you can't just say, oh, well, it's a file name ending in .jpg and therefore it must be JPEG. What you really need is the browser to supply a multi-purpose internet mail encapsulation message at the beginning of the stream, and that will tell us what the HTML type is. So when we're modifying our data to give us new types of processed data, we may also have to go into our HTTP daemons, our Apache web servers, and modify those in order to properly map the data type into a new MIME string. So we get access to these MIME strings through a request for comment. This is called the 1521, and there's a few commonly held process data types, such as text stroke HTML, which is essentially just the HTML that's been formatted, hopefully in a regular fashion. You can get image data, such as image/GIF, and if that's in the stream, the browser should know how to interpret that and display it, but not all browsers do. And there's another form of text that we may hold as common, the RTF, which is really just a Microsoft proprietary format. And so this MIME string comes in the header, and we can't rely upon a file name suffix. And so when we build an HTML viewer, we want to be able to set our MIME type. We want to create an application that renders the HTML to the screen, and we can do various things with it, such as building help files. We can also build browsers. So then the question becomes, well, what do you need to render HTML for? And the answer is it's process data. You decode it at the presentation layer. It's a standard markup language if it's used properly. It enables the creation of browsers. You can use it for documentation viewers. You can debug your HTML generators, which is kind of what we're going to do. We're going to build our own HTML generators. And you can debug web servers. And making something generate HTML, it sounds like, well, why would you do that? Why don't you just type it in? And the answer is because this is dynamically created HTML from process data. So you're actually going to run a program that sits in the server, responds to user queries, and then generates the HTML dynamically. Now that may foil a search engine optimization strategy such as Google spidering of your website, but in fact, if you want to do any kind of commerce, you're going to be generating dynamic HTML. So then the question becomes, okay, so how do I render the HTML? And the answer is, well, I've got a handy-dandy HTML viewer, and it'll render some canned HTML for you, and that'll give you a mechanism whereby you can proceed to look at your HTML. And in fact, it can even grab some URLs off of the web. So then the question becomes, okay, so how does this work? And the heart of the HTML viewer is a so-called JavaX Swing JEditor pane, yet another class for you to know about. The JEditor pane, or what I'll call the JEP, is embedded inside of a scroll pane. And the scroll pane, as you know, is a decorator, which essentially gives you scroll bars that go up and down. They call them elevators, those little boxes, and also left to right. So that way you can kind of browse around inside of what is essentially a large amount of data. And what you want to do when you are going to set the content is you want to set the content type using the MIME type. And there's the MIME type, text HTML. Once you've set the content type, just set the text, then do a display, and bang, you're done. Let's quickly switch to an example and see if we can get a demo to run. So here's an HTML viewer, and you can see where it says show URL, and it's being input a URL right in here, which then proceeds to create the HTML viewer, takes something called URL utils, converts the entire URL into a string. That's convenient. Reaches out to the web, grabs out the URL, takes the whole thing, converts it to a string, and then sets the text in HTML. So then you're saying, well, okay, well, how does that work? And the answer is, well, it sets the content type using the MIME type, just as described, text stroke HTML. Then it sets the text, and once that's done, it does a display. So let's see it work in action, and here we go. A demo that works. Who would have thunk it? So now we've got the scroll mechanism. Here you can see the scroll pane, which allows us to resize and scroll around in any sized window. This can work reasonably well even in a small area, such as on a cell phone. Nothing works to, there's no click response here, right? So not listening to the clicking. What we're doing is rendering the HTML at this point. Listening for browsers to do clicking and that sort of thing requires a little bit more complexity in the code. So let's get back into the code a little bit and see how the HTML viewer works. So after you set the HTML and you set the context type, the content type, and then you set your text, what it does under the hood, and this is where things get a little complicated, is it makes a little document. It then proceeds to create what's called a string reader. It then makes what's known as an editor kit. Goes into the editor kit, tells it to read the string off of the text, and then proceeds to do a display. And that's a little bit more code than I want to get into right now. And certainly there's a lot of Java doc for you to read, and this is all out of the JEditor pane. So that's all kind of hidden. It's under the hood. We don't kind of have to care about it. But for the moment, when we make an HTML viewer instance, what we're really doing is we're displaying a closable JFrame with the title HTML viewer. We get our content pane and set up our grid to have as many rows as we want with just one column. We throw in the HTML pane, and then we proceed to set the size, and then we make it visible, and that's it. So JEditor pane does almost all the work for us, which is very convenient. Back to PowerPoint. So the MIME interface, the ones we care about, it's text stroke HTML and text stroke RTF. That's going to set the type of the data in the JEditor pane. Text indicates it's going to be text in the string. HTML indicates that we've got HTML data. And And that's all we really need in order to inform the JEditor pane how to process the HTML data. So multi-purpose internet mail extensions, they date back to the first time somebody decided that you needed to send something other than ASCII text along with your mail. So your mail transfer agents had to be extended in order to be able to pass through data that was not just text. And so what we'd like to do is we'd like to sort of know a little bit more about it. In the beginning, mail was just ASCII, and somebody wanted binary data. So the entities on the internet called mail transfer agents were meant only to pass ASCII data. So what people would do is they would UU encode or base 64 encode the binary data, but in order to identify the type of data, they needed what are called the multi-purpose internet mail extensions. So the mail transfer agent is simply a store and forward mechanism that moves mail from one node to another node. And the node is just a computer that runs a mail transfer agent, probably running something reliable like, I don't know, Unix or something embedded. And so in this case, all we have to worry about is text passing from one place to another. So when we think about Word documents are just another specific type, and they represent what we'll call processed data. The GIF format images, that's another kind of processed data. Sound stroke AIFF, that's the audio interchange file format. That's more processed data. Sound.a/AU, that's a MULA encoded 8-bit companded processed data. There's no limit to the number of different data types you can transmit, right? You could just make one up. MIME lists a whole series of different common data types that browsers can try and decode. So here are some common examples, and there's lots of others, and they're all documented in the request for comment 1521. So what do I use MIME for? Well, I use it for browsers. But browsers were relatively recent, right? That's the graphic user interface imposed on the web that started around 1994. Mail predates browsers, and in fact the internet predates browsers, by a very long time. So browsers are really meant for the web. Mail and other stuff, that dates back to the 70s. JEdit panes, they use MIME data types, and the common ones listed on the bottom: text HTML, text plain, text RTF, and image GIF, all very common data types, and JEditor panes can process all of those. So then the question becomes, all right, so how do you generate HTML? Well, HTML is just strings, and you can generate it in any one of a number of different APIs, some of which allow you to generate very structured documents. But if you want, you can just type in the strings, or you can synthesize the HTML programmatically, or you can try and write your own toolkit for HTML synthesis, and you can control your own HTML generator. And here's a way you can synthesize HTML. We'll just pass in a string and make sure it's wrapped with an HTML tag, and this will generate HTML synthesizer. So now when somebody says get HTML hello world, what it'll do is it'll return a string that is surrounded by HTML tags and new lines to help make it readable, although that won't help it get rendered differently because these aren't in a paragraph form or surrounded by break tags, and so it'll just print out hello world. So now you can use your HTML synthesizer to generate a list item. Here's a list. LI stands for list item. That's a tag in HTML. And here we can get a list item and have it return list items surrounded by HTML. And we do that by nesting it inside of the HTML invocation. So list item surrounds the list item by the LI tags, and then the HTML tags surround that. And that's the HTML synthesizer in a nutshell. Let's try another example. So what we'll do in here is we'll go into the HTML browser that I constructed, and this one is a little bit more advanced. Now you can build your own little browser, and voila. It goes in, grabs the data, and if you want, you can check out my new store, and when you click on it, the browser listener will retrieve the data under the link, which is very cool. And if we go to the File menu, we can see that there is a mechanism for going back. So just like a regular browser. And if you want to, you can go to the Java courseware, and then you can go back, and then you can go forward. It's just like a little browser. So now you've got a mechanism in place which not only can retrieve HTML, but it can open the HTML from the local file system or even open RTF. And if you like, you can view the source code. Let's do that and see what we get. And now you can see the actual source code in the web page. So that's a mechanism for building your own browser, all within your own Java program. And when you start to look into this, what you'll see is there are things here called the browser listener, which is a hyperlink listener. And what it does is it proceeds to use things like clicking, and then proceeds to load new URLs with a thread into the JEditor pane. That threaded load is important because you don't want your interface to get hung up while you're busy being I/O bound. And in general, when you're processing HTML and trying to read data off of the net, you want that to work inside of a thread. So when you look at the threaded load, what you're really seeing is a thread that's being held internally. The threaded load is listed as runnable, and then what it does is it sets up its priorities, sets up its run page, and then it says, I'm going to set the page to this URL, and just the act of doing that inside of the run method inside of a thread basically makes it a threaded load. So when we look at something like set page, what we're really seeing is something that comes in from the JEditor pane that takes an arbitrary URL and handles the loading of the page for you. So that's all done under the hood inside of the JEditor pane. So what you're doing here is you're just setting up a thread that's essentially going to call set page inside of the JEditor pane, and bang, you're done. The other stuff about the daemonness and the priority, well, that's just a little bit of extra fluff that you don't kind of have to worry about too much. So then when we go into the main method in here and we look to see how things are going, it says that it's going to call super, and what super is doing is it's going to the closable JFrame and setting up a title. Then it calls init, and that's going to set up your menus, and here's the menu items being set. And here you can see the accelerator mnemonic for file. You should also be able to see the accelerators for Control O and Shift Control O and Control S, and you could see that there was a backward and a forward all being set up inside of the run menu. And then the rest is just layout to help make it pretty, and that is and that's the browser. It's a relatively small amount of code, but it can be fairly useful. And that's what I have for you for today. Thank you very much. Bye.